All right, so welcome back. We covered mostly everything with regards to loops, but I did want to do one more exercise here at the end. We'll only do it in one language, and I'll let you choose which one to do. But it's going to be very, very similar to what you're going to be doing in your next hack this week on loops. It's kind of the reverse. We're doing a loan amortization table. So when you take out a loan from a bank, say to pay for a car or something like that, you have a monthly payment. That monthly payment is expressed as this equation right here. That formula is derived from compound interest and stuff like that, and to get it down to exactly the number of payments that you have to make, considering the interest that you have to pay. Because when you take out a loan from the bank, of course, it's not free. You've got to pay some interest in addition to paying the loan back over the course of the loan period. The rate here is the rate per period. For example, 5%, if I took out a loan at 5%, then I would divide that by 12 for the monthly interest rate. N here is the number of periods, the months in the loan. So if we read like a 5-year loan from the user, we would take 5 years times 12, because 12 months in a year, and that would give us 60 terms for that loan. So for example, $10,000 here, that's the principal, that's the amount that you take out. Then your monthly payment would be $188.71. Okay? So, but you don't pay every month. You pay a little bit to interest and a little bit to the principal to pay down the loan. That changes from month to month because you're paying down the loan. You don't owe you owe $10,000 in the first month, but once you pay it down, you owe a little bit less, and so you pay a little bit less in interest. And that's what leads to this loan amortization table here. If in the first month, again, we have $10,000, well, we pay $181.71. Actually, only $41.67 goes to the interest. The rest of that payment here goes at the end of that month to be $9,852. Now, next month, we don't pay $41.67 in interest because the balance is now lowered. So we only pay interest on the current balance. And this is known as amortization. When you get down to the end of the loan, you're paying almost pennies in, I don't have the full table here, but you're only paying pennies towards interest and more towards the actual balance. That's why it's always good to pay down the balance as quickly as you can, assuming that your interest rate is higher than, say, inflation, right? 5% is definitely high. Well, 5% is maybe matching inflation right now, but traditionally that doesn't match inflation. So if you get this insanely cheap loan, like a 1% interest or 0% interest, don't pay it down, right? Because 5 years from now, inflation will actually mean that you've made money from the loan if it's that small. But anyway, that goes beyond what we're going to cover here. Instead, we're going to write a program to produce this loan amortization table. Right? Now, votes, C or Java? C? Oh, okay. C. All right. Java. Oh, I think I saw slightly more C votes. Let's go ahead and go with C. Over here, you could do the exact same thing, of course. It's just syntactical differences. Now, I do have a start on the program already. When you write a program, what do you need to have up here at the top? Header documentation, right? The author, the date, and the purpose of the program. Over here in Java, where would that end up being? Right up here on the loan, right? And I can cut and paste this if I want to as we go along, right? There we go. Oops. There we go. There, I got my header documentation already. It is tied to this to the class declaration here, and that's because you can hover over it and you can see this formatted text here, and it allows you actually to use arbitrary HTML in there too. So if you want to link to something external explaining how loans work, you can do that, right? Yeah.
Is it because you put it right before the method, or like?
Yep, right before whatever's on top. This doc style comments is associated with that. If I have a variable down here, int foo, right? Public static int foo public, and if I put some doc style comments right there, then foo represents something, right? Then if I hover over that, it's foo represents something is associated with that. So it has to be immediately above.
So it has to be a forward slash star star.
Yep, forward slash star star, and you saw very briefly that I had there were some annotations here too. Author, right? You could put that in here instead of using author. Author, date. I don't know if date is supported or not, but those kind of annotations are recognized by the doc styler, documentation styler. Right? And again, you can put in arbitrary HTML here, right? For more on loans, see href wikipedia.org, right? Wikipedia.org. And that, and I should go HTTPS, there we go. There we go. And when I hover over this, you can see that that's hyperlinked now. It's kind of small, I'm sorry, but you can probably see it at home. And when you click on it, note that Eclipse has a full web browser built into it, right? So because if you're doing web app stuff or web development, then you'll want to render your page, and so it takes you right there. Right? And again, the whole purpose of doc style comments is so that you can run your doc tool and produce all of these documentations, so you can throw it up on the web or throw it into a PDF and then publish that with only pushing one single button. Okay. All right. So what's the next thing? I bring in all the libraries that I'm probably going to need. I brought in the math library here because if you look at the formula here, I'm probably going to want to raise something to a power to the negative n. Right? Okay. But otherwise, if I were not using anything in the math library, don't bring it in. Right? Don't include unnecessary libraries because then you get into the habit of just include everything, right? And one big giant include, even though you don't use that stuff. Be more intentional with your code. Right? I'm checking to see if I've got command line arguments here, an appropriate number. Because remember, what do we need? We need the rate, the principal, the annual rate here, the principal, how much you're borrowing, and then the number of years that you're taking this loan out for. So again, typical auto loan here, $10,000, 5 years, 5%. Okay, that's for a used car, obviously. Right? All right. So how many do I expect? 4 command line arguments. Why 4? The principal, the annual rate, and the years. But what's the first command line argument in C? The executable file name, a.out. If I compile it into an executable file, it's called a.out, right? What does that look like over here in Java? Well, first of all, what do I need? I need a public static void main string args, right? And it's not argc. What is it? Args dot length. And it's not 4 anymore. Why? It's 3 because in Java there is the executable file name doesn't exist. You know what this class is called. You called it. You named it. You named it loan. Right? So it's not necessary there. System.error.printf. Right? Somebody was asking about this before class. The difference between out and error is just in Eclipse. This will get printed as a bunch of red instead. Right? It is better to use error if it is an error message. It is better to use out if it is not an error message. Question?
Yes, since we're talking about printing, I had a question. That last task we did, we were printing off a lot of lines. Is it considered bad form to have multiple lines separated by /n in one print at the end?
Not really, but you can, like in Java here, it's not great to have long lines. So one thing that you can do, at least in this IDE, is hit enter and it'll just concatenate this stuff so that it's all at the same line. I don't like the way that it does it though. I prefer that everything nicely lines up, right? And now the general guideline is that you should only have 72 columns. That's really old school guideline. Why? Because old CRT monitors The green screen monitors had 72 columns, so don't go beyond that. I've gone, now what is this column? 76? Right, that's the 76th column right here. This is line, column, and number character down here. But it's just a guideline. Right? Definitely don't have super, super long lines, but make it readable. All right. Then I read those command line arguments. How do I do that in Java over here? Principal is the first one, the amount that you borrowed. So I want to read arg v sub 0, but I don't have a to f. What do I have? Args, thank you. Double dot parse double args, right? Same with this, but again, it's arg v or args sub 1. You can name it arg v if you really want to. Java won't care, I believe, but it's more usual to use args. I'll show you a trick here in a second. And then integer dot parse int for the third one, which is 2. Arg v args. All right. Oh, I just like being different. I like to call it arg v. You can right-click any variable, refactor, rename, and you can rename it to whatever you want. And all of them will be renamed that are in that scope. Now, of course, I don't want to do this. Instead, I want args, because that's the usual way of doing it in Java. Right? All right. Now, what's next? What's the very first thing we need to do? We need to compute the monthly payment here based on those things, using this formula right here. So let's go ahead and do that in C first of all. So is P a very good variable name here? Double P. What does it represent? $188.71. The principal is say 10,000. I've already got a variable for that, right? P is the monthly payment, in fact, right? Monthly payment. Much better variable name there, right? And it's compound word, so we camel case it, lower camel case it. And I use this formula right here that's derived from finance. Where did it come from? It came from over there, right? Don't worry about it. Rate times principal. Be careful though, the rate is, say 5%, that's an annual rate. If you had a 5% monthly rate, that's called loan sharking, right? And that is, I'm sure that exceeds legal limits. But in any case, what we need to do is we need to divide that by 12 to get the monthly rate. Now, 12 is an integer. Is there an issue here with dividing rate by 12 as far as integer truncation goes? Sorry, I should have be clear that this is actually annual rate. One of them is a double, right? So a double divided by an integer results in a double, and we're still good. Times the principal, and I need to make sure that this is in the numerator here, divided by 1 minus 1 plus the rate, which is, again, is the annual rate, divided by 12, and here we're getting into a long line, and raised to the power negative n. Right? So, is a caret the way that you do that? Nope. So how do I raise something to a power? X to the power y in C. Nope, like m underscore pi, m underscore e, those would be constants. What I want is a function to do it. POW. Yeah, nobody's ever called it POW. That's a POW, right? POW for short for power. Right? Yeah, prisoner of war in C. Right. So, I'm putting this entire expression here as the base, as it is right here, 1 plus the rate, where the rate is divided by 12. And then I've raised it to the negative n. To make a variable negative, all you have to do is put a hyphen in front of it, negative n. All right, let's make sure that this is actually compiling and I don't have any problems so far. Uh-oh. Oh, not n, what is it? N should be years times 12. So let's go ahead and go back over here, and I'll replace it with years times 12. Right? Now you could put that up here into another variable, int months, right? Equals years times 12. Right? And half a dozen of one, 6 of another. Right? All right, let's actually print this out and make sure that we're getting the correct answer. Printf, monthly payment. Let's format it nicely. It is dollars, right? And dollars are only two decimals of accuracy, right? Let me go ahead and get rid of that just for now to show you something. And then we'll print out the monthly payment. Remember, the monthly payment for this particular input would be $188.71. So let's test it. All right, oops. Okay, fine. What do I need if I'm going to actually use the math library now? LM. Right. Oops. Oh, %f still. Forgot my %f. Now you're happy, right? Now, if I don't provide any command line arguments, it's going to complain about it in that argv check. Otherwise, if I provide $10,000 at 5% interest for 5 years, right? That was the order. Then I should have a payment of $188.71. Wait a second, change, right? So there's fractions of a cent here. Are you able to pay for fractions of a cent? At a bank, no. You can buy like fractions of like stock or something like that, or your stock is worth fractions of a cent. All right, finance does allow that in some situations, but not with loans, right? You don't go to the donut shop and pay with, $5.28, 28 and a half cents, right? There's no way to even do that, all right? So what do we need to do? Round, okay. So let's round that monthly payment. Monthly payment is equal to, there is a round function, right? It's in the math library. So let's round that monthly payment and then put the rounded value back into that variable. And let's see what happens here. You could do a 0.2 here, and that's what I was going to do, but then it would have hidden the fact that there's a fraction of these cents over here. Not only that, but it's just for the purposes of printing. It rounds it for you, but only to format the printing. It doesn't change the variable itself. Right? To show you that, let's print it out once and twice. Right? And let's get rid of this just for now. Run that again. And yeah, it rounded it for the printing purposes, but you can see right here that it did not change the actual value. Right? There's still fractions of a cent in there. Yeah. The 0.2 will round from printf. Printf rounds, yes. Right. So let's see what happens now when I actually round it. Run it again. What does round do? Nearest whole number, right? Nearest integer. Is that what we want?
No.
Nope. We want it to round to the nearest cent. So ideas?
0.2 somewhere?
Okay. How would I do that? If I have 188.71 and then a bunch of numbers, I could take this little dot here, and what could I do with it? Move it over. Move it over. So multiply by 100, right? Right. I could take this, put it in a pool of water. That dot will float over here, and then I can push it over, and then I can take it out of the pool of water. Right? What did it just do? It floated over there. That's why we call these floating point numbers. The period, the decimal, can float, right? And it's like scientific notation. You're multiplying by some, power of 10 to normalize it. Right? In this case, I'm not normalizing it. I want to shift it over so I can round. And shifting it over, like you said, is multiplying it by 100. Now, does that solve my problem? Now my payment is $18,000 each month. That's more than the loan itself, by the way, right? Divide the round, right? Undo your round, right? And now we're back, and that's exactly what we want.
Is that the most efficient way to do that?
Yep. Yeah. Most efficient computationally, I have no idea, and I don't care, because most efficiently, as in, I am reusing and adapting something that already exists. The next topic is functions, and we'll be writing our own functions. And why do you write your own functions? So you can reuse code, right? So you don't have to, have cut and paste solutions over and over and over again. Not only that, but you don't. If there's already a function to do it, right? You use it. Right? You like to be lazy, and this almost does it. All I have to do is tweak it a little bit, and I get it to do exactly what I want. It doesn't round to the nearest 1/100th place, but I can make it do so by slight adjustment here. Okay? I'll go ahead and get rid of that now. So I'm satisfied that this works so far. $188.71. Great. Now what's the next step here? I want to produce this table right here. So probably want to print this header out here, right? Is that going to be part of my loop? No. You can just do it once, right? So printf this, that's going to be the month, the current balance, the amount of interest that we pay, the amount of to principal that we pay, and then a new balance. Oh, go away. All right. There we go. And by the way, let's go ahead and make sure that we are keeping our Java version up to date, because there are enough hands here that was a critical mass. Let's do both. Right? What's the only difference? Math.round and system.out. I don't know why it keeps getting rid of that for me. Dot. I might as well just wait to the end and do a find and replace and all that stuff. Right, we're still good here. Just to show you. Uh-oh. No, I have to go to run configurations and provide those arguments. $10,000, 5% at 5 years. Apply, run. Uh-oh. Oh, there, you're right. Sorry. I didn't hear you. Math.pal. Math.round. And now we're good to go here. Right, $188. Oops. Whoa. Monthly payment. That's RTM. All right, you can't see it. It's probably pretty small. But for those of you in the front rows, what is the return type on this function? It's a long integer. So if I have a long integer divided by an integer, what ends up happening? Truncation, I just lost my 71 cents. So solution, make one of them a double. And
Is there like a round double method?
I'm not sure. Let's find out. Right. There's a round. There's another round. It takes a float, but it's also going to return an integer. And there's a pow. Those are the only two round functions I see. So, yeah. And by the way, I'm actually in the Java library right here. This is what these are comments that the Java folks have left for the standard math library right here. Right? How does pow work? Right? Well, it calls this strict math.pow. How does that work? It calls this fdlib.pow.compute. Let's go ahead and take a look at what that looks like. And then complicated, complicated, complicated. Right? Wow, cool. It's Several hundred lines of code for the POW function right there. Or it looked like, maybe. It probably ended before. But there's the actual POW function that gets 341 up to 700. So yeah, 300 and some lines, 250 lines of code for the POW function when you finally get to it. Right? Let's get rid of that, get rid of that, get rid of that. All right. Again, do we care? Nope, it just works. Just use it. All right. There, $188.71. Next. Again, I want to produce this table. So I want to produce the month, the current balance, update the balance, compute how much of this $188.71 goes to interest, how much of it, the remainder, goes to principal, and then update the principal for the new principal. Right? And then set yourself up for the next iteration of this loop. So obviously I'm going to want to write a loop. What kind of a loop do you want to write? A for loop or a while loop? A while? Do we know how? Don't we know how many times it's going to execute?
We do know it's the months, so yeah.
Years times months, right?
Yeah.
So I would argue that a for loop is probably a little bit more natural, intuitive. You can do either one, right? And we're not going to, even when you submit code, if you wanted to do this exercise in a while loop, perfectly fine, go ahead, right? But let's go ahead and do a for loop because it just seems a little bit more natural. Now, should I have an iterator variable called I? Generally, that's okay. But what is I representing here right now? I'm going to do this for 1, 2, 3, 4, 5, ... What is that? It's a month. So call it month. Right. Do I start it at 0? Doesn't look like it. So I'll start it at 1. I will go up until while month is less than or equal to 12. That would just be 1 year, right? Times years. There we go. I, or month, plus plus.
Does it matter whether you do less than equal to or just equal to?
If you do, well, not equal to is what you would want because it's a continuation condition. If you did strictly less than, then you'd have to manually add 1, and then I'm thinking, where the hell did that plus 1 come from, right? It's a magic number, right? Less than or equal to. Right?
Wait, so why does it have to be not? Why can't it just be?
Because while it is not reached 60, right? While it's 1, 2, 3, 4, 5, 6. Once it reaches 60, and then you'd want to go, even there you'd have to add 1 because when it's 60, that's the last month. You still want to compute it. Although we're not going to want to do it in the loop eventually, and you'll see why here in a second. Right. Okay, let's go ahead and print stuff out, printf. %d for the month. The next thing that we'll print is $.2f for the current balance, right? $%f. There we go. 1, 2, 3. Another dollar figure over here. 1, 2, 3. Another dollar figure, and finally another dollar figure. All right. So I've set myself up for this, but I need to compute each one of these things. So the first one is just the balance, right? The balance is do I have a variable for the balance? Nope. So let's create one. So before the loop, double balance is equal to, before you start the loop, what's your balance? It's the principal, the amount that you've borrowed, right? And then the balance goes down each month after that, okay? All right, in the loop, I'm going to need to compute how much interest for that month, and then the remainder of my payment goes to principal. So to principal and to interest, let's say. So double to interest or monthly interest, right? Or whatever. And I don't know what that is yet. And then double to principal. Right? So how do I compute that monthly interest? It's the annual rate divided by 12 to get the monthly rate, multiplied by your current balance. And you need to make sure that this is in a, I think that it's okay, but in any case, there you go. Right. You are never going to go wrong by putting clear parentheses anywhere. Okay? What about the how much do I pay to principal then? Monthly payment, because that's the total monthly payment, right? Minus to interest. There we go. And so again, this is the balance to interest and to principal. I've got almost everything except for the new balance right here. All right. So what is my new balance? Remember, if I start out with $10,000 and I pay $147.04 to it, then I'm left with this much. So it's whatever the old balance was minus the, the amount that you get to principal, right? Because you got to pay the interest, right? You got to pay the piper there, pay the bank. Okay. Let's test it and see what it looks like. Where am I? Okay, honors, there we go. Loan. Monthly payment. Monthly payment. I misspelled it. Right? I think that was it. Okay, and then -LM. There we go. Let's run this using the same parameters as before. Doesn't look good, does it? What did I forget? All right, let's end the line. Let's see, make it look like an actual table. It's a loan amortization table. Come on. There we go. Run it. Okay. Doesn't quite look like the table, does it? What's wrong? I do need to end the line up here too. The balance is never changing, right? I always compute a new balance, but I never change the old balance. So what should I do? The old balance is equal to the new balance. And is that where I should be doing it? Before I print it? Let's find out. Old balance, new balance. Always the same. So when should I do it? After I've printed it. Okay? So this is looking a little bit finer now. There we go. So let's check to see if those first few months agree with our output over here. Right? So in particular in month 6 here, we've got 63 cents, yep, 58, yep. Right. All good? Right. It seems that way, but that's only because we only looked at the first 6 months. There are pennies, or fractions of a penny error that is compounding here. Remember that we had to ultimately round the monthly payment because we had those fractions of a penny that we had to get rid of. What else might we have to round in order to take care of that same issue? To the interest, right? And I can take care of that immediately by going round this entire thing, but make sure that you're multiplying it by 100 and then divided by 100. Right? Now, do I have to round to principal? Monthly payment was already rounded to the nearest cent. To interest was already rounded to the nearest cent. So do I need to worry about to principal? Okay, if you want, if you're really hyper paranoid, we can. Yeah, but it's subtraction, so it's probably okay. Yeah. 100 point. Not in C. Not in C. In Java, we'll have to do that over there. If you want to make it, there's nothing stopping you. In fact, that looks really nice because it reminds me that, oh yeah, it's money, right? Now that looks like $100, right? Well, it's not $100, it's 100%, so maybe that's wrong, I don't know. Right? New balance, do I have to worry about that? Well, if 2 principal was already rounded to the nearest cent, we're probably okay. Right? But again, if you want to be paranoid, round it, but multiply it by 100, and then divide by 100, okay? And that will all look much better. There's still an issue here, though. First of all, the formatting doesn't look very good. Right? Does that look like well, I mean, it looks fine in spots, but like one step over, right? So here's some tricks that you can use. What I'm going to do is I'm going to format this with 5 columns. Why 5? Because when I print month at the top, M-O-N-T-H, 5 columns. Right? I'm going to print this with 10 columns. Right? 10 columns. All this money, 10 columns, so that all the periods are going to be aligned. Ooh, now that's a ledger table to be proud of, right? Now the dollar signs are over here, yeah. So what? But that's how real, amortization tables look like, right? They align all of the periods, all of the decimal places here. It doesn't matter that there's a bunch of white space to the dollar sign over to the right. In fact, you can forgo the dollar sign entirely if you want. You could also shift it the other way. Right now it's right justified. You can go left justified with a negative. It's not going to look as good in this case though, right? Because now we're back to the default there, that it's going to be left justified, and that doesn't look good eventually. Right? So I'll undo that. Lots of tricks that you can use with printf like this to make everything look nice and shiny.
Do you need 10 columns, or do you need less columns?
No, I just did 10 because I knew that would be sufficient. So 2 decimal places, the decimal, and then that leaves me 7 spaces for the actual number. I mean, if you want to go larger, smaller, whatever, but if you went smaller, then you wouldn't be able to handle most, reasonably loan amounts. Right? What about that last month there? My principal is down to $186. In fact, this looks fishy. This looks really fishy. Yeah, I screwed up here, didn't I? Times 100 divided by 100. It didn't, there we go. That looks a lot less fishy. Of course, you need to pull out your calculator and do this 60 times to make absolutely sure. And then, of course, you need to cross your fingers and make sure that you're not screwing up in your calculator, right?
There's 14 cents up there.
Yeah, what the heck is going on with that last month there?
Is just the rounding?
Rounding, but also, again, as an artifact of the rounding, right? We're paying more in interest than we are in the principal, right? So at the very end of the month, you might have to handle that one a little bit differently. Just like remember the Zune bug, right? You have to handle that exceptional case differently. We probably want to end this early and then handle this last month separately, right? And just tack on that 14 cents here, because the bank's not, some banks will forgive it and like, all right, fine, you paid off your loan. The balance is less than $1, we'll forgive whatever, because we don't want to deal with it. But usually the banks are going to want their money. So we'll go ahead and tack on whatever remains over here to the principal. And how would we do that? We would stop short. And so now I am going to go back and change this to a strictly less than. And like any good programmer that doesn't want to do something immediately, I'm going to put in a to-do. Handle the last month separately. All right, and I'll let you do that on your own. All right, let's take this chunk and put it over here in Java, and let's figure out what we should do here. Math round, math round, math round. System.out.printf. What was the trick there? I forget. Oh yeah. I'm going to have to do periods on all my divisors. There we go. And it agrees all the way to the end, except of course for that last month. And I will keep my to-do there. Right? All good programmers that want to procrastinate will, as a reminder, put in a to-do as a comment. Why is that so common? Because what you can do is you can go down here to using your IDE and, how do I view something? Window, perspective, show view. Do you see tasks? There we go, tasks. All right. And I've added this, this tab down here. What does that do? It goes through my code base and finds all of the marked up to-dos. And so I have this entire to-do list of, okay, I still need to do that. You can double click on it and it takes you to the piece of code that you still need to write. And if you have 50 of these things, then you can knock them all out at the end, at the very last second. Don't do that. Don't work at the last second. But if you don't want to do something immediately, you can always put in a to-do to remind yourself. Right. Question?
Oh, no, well, I was gonna ask if the code worked with the, go back to the table.
Sure.
Okay, good. Oh, yeah, you took off the last.
Yeah, I took off the last one, remember? And I, and I put in that, you need to do it. You need to do it, not me. All right, questions on that? And this is highlighted here. Go over to tasks and, wow, okay, fine. Close you. And open it back up. There we go. Oh, wait. Why are, I don't know why it's highlighting like this. Probably this coverage here. This is JUnit tests. What is it? Clear it. There we go. Usually, if you've got some markup or something like that, and you just need to clear it, these X's over here will clear stuff. And so, for example, in the console over here, I've got output. You can clear it by Xing it out. All right. Questions on these kinds of loops, I guess? No? All right. Hopefully that exercise was not that boring. You're going to do something very similar, but instead of a loan where you're paying it back, you are putting into a not a savings account, but a 401k. And you're watching that and you're putting in an extra amount each month, contributing whatever, and you're seeing how much money you might have at the end of your retirement.
Is that a wrap or a hack?
That's your hack this week. Yeah.
Would it be okay if we decided to not round anything, any of the actual variables, and just round in place? Would that be okay too?
That would not give you the same answers because it would only be hiding the compounding floating point errors, right? It would end up mysteriously some penny eventually. If it's like a quarter of a penny, then every fourth month your figure would be off by a penny, and the eighth month it would be off by 2 pennies, et cetera, right? And at the very last, you'd be off by a few pennies. Not that big of a deal in real life, but I'm sure that would not, there are financial rules and regulations and compliance that would be violated everywhere somehow, right? And there are rules what happens to those extra pennies, whether or not it's a loan, whether or not it is a savings account, and so you would, in a real loan or real program, you'd have to account for those fractions of a cent and conform to whatever rules financial regulations tell you to do. So in fact, you probably wouldn't even want to do a double. In Java, you would probably want to use a big decimal. A big decimal is going to allow an arbitrary number of digits. Or you can configure it so that it's always accurate out to 100 digits or something like that. We're not going to do that here, though. We're not a real financial application here. Right?
When we use money, it's best to actually run
That or so Java currency. There's a currency class that you can use Java Money and the currency API, yeah. And then it localizes so that you can use, yen, you can use euros, you can use, maybe Bitcoin is supported by now, I don't know. Not concurrency, but currency, right? Currency and money. And again, we're not looking for that in your hack, but if you wanted to try it out and check out and see what it looks like, don't worry about that. Currency unit, right? US dollars, get the currency of the US dollars, and then you can add a dollar, you can subtract a dollar, whatever, right? Okay. All right. Let's go ahead and get rid of this. Come on. There we go. And start on our next topic here. Markdown. Open a new window. Functions and methods. So, a function, or in Java they're called methods, is a reusable unit of code. And again, why do you want to use functions? Exactly. So you don't have to, and also you can reuse them, right? In your own. Let me split right. I'm working behind the scenes here, so don't worry. All right. So for example, you're already familiar with main, printf, or sqrt in C, right? Do you know how sqrt works? Not without ripping open the code and finding out, like we did with the Java math library. But ultimately, do we care? No. It's just a button on our calculator, right? Have you ever worried about how that button actually computes its value on your TI-80s when you hit that square root button? No, you don't care. You just want the answer. And by putting stuff into a function and not worrying about that stuff, it provides a level of abstraction where we don't have to worry about those details, right? You are familiar with functions, say, from math already, of course, too. F of x is equal to x squared, right? What is the name of this function? Ever think about that when you do this in math? F, exactly, right? Mathematicians aren't that clever. It's just a function. So what do I call it? F, I guess, right? Well, in code, we can't call all of our functions F. We want, well, first of all, there'd only be one function called F, and then we'd be done, and we wouldn't be able to have any more functions, right? But also, we want descriptive names. That's why we call it sqrt, or sine, or cosine, right? Sin and cos. Right? But the idea is the same. It computes a value, and you're given this input. Those parentheses, when we call a function like round and provide parentheses, that's from math. That's why we use parentheses. Right? And these are called parameters. This is an input to this function. Right? The input is x, and the output is x squared. Right? It returns a value, right? Implicitly here is if I gave 5 as an input to this function, it computes 5 times 5, 25, and then that's the value of the function at that point. Right? And that becomes the output. You can also have multivariate functions, right? We're still talking about math, right? F of x, y, f of x, y, z. You can also have functions with no inputs. What would that look like? It doesn't depend on x. So if I've got the Cartesian plane here, it doesn't depend on x. It's say f is equal to 5. What does it look like? A vertical line, or a horizontal line, right? So you can have constant functions in math, and of course you can also have it in code. Right? And again, the reason that you want to use functions is because it facilitates code reuse. You don't have to copy pasta huge chunks of code. Instead, if you've got a piece of code that is useful, say, for example, always calling the round function, but before you do, shifting it by 2 decimals, and then after you call the round function, shift it back. Maybe if you're doing that multiple times, 3, 4, 5 times, instead, what you can do is you can take that code and you can put it into a function called round to sense. Right? And once you've got that function, you can reuse that function as many times as you want, without having to repeat that code over and over and over again. Now this particular piece of code that rounds to cents, like for example right here, it's only a one-liner, right? But it has a better name. Instead of round, it says round to cents. So that's another justification for why you would want to put something into a separate function, right? Because there's a clearer, more understandable label to it, right? You can call or invoke the function once you defined it. This goes along with the dry principle, right? Dry principle. Right. Let's pull, there we go. The dry principle is don't repeat yourself, right? Do one thing and do it once, then reuse that thing. The dry principle can also be applied to documentation. Only have one point of documentation. Don't have the same documentation repeated over and over and over again. Don't repeat yourself. Right? DRY. Right? And of course, it provides procedural abstraction. Right? So again, my question is, how does sqrt work? Now, seriously though, does anybody know how it works? Has anybody tried to?
Like some bit math that they do.
There might be like a bit mapping trick of some sort. But if you take let's see, what if I change this question to sine? Now think calculus. How would a calculus person compute sine? Yeah.
You do a bunch of guesses until like numbers.
Okay, hold on to that thought for a second.
There's a Taylor series.
Taylor series, right? It could be a Taylor series. Or what you just described was numerical interpolation. Right? You interpolate something by making an educated guess. Okay, that's too high, right? So make another guess, another guess, another guess until you get down to arbitrarily close to what you want, until you converge onto that function close enough, just like we did with the AGM last week, the arithmetic geometric mean. Right? All right, it could be a numerical interpolation, right? It could be a Taylor series. The answer, though, the real answer is who cares? Right? We simply want to use that functionality and not have to worry about the details. Right? By encapsulating functionality into functions, then we don't have to think about the details, right? And that's actually the worst thing that you can do when you're coding is to lose focus. If you have to juggle 2 or 3 things in your head at once, you're not focusing on any one of those and you'll eventually drop them all, right? You need to focus on one thing, and by saying, well, I don't know how the sine works, I just call it, I don't have to worry about, the details of how I'm going to compute the sine function. Is it going to be a Taylor series, or do I need to pull in a numerical interpolation method off the shelf or something like that? I don't want to have to worry about that. That's not the problem I'm trying to solve. The problem I'm trying to solve, in part, uses the sine function or the square root function, but I'm trying to solve a different problem right now. Right? All right, standard libraries and libraries and external libraries come with a lot of testing, debugging, and optimization that you cannot hope to replicate. Right? The standard library is over, well, the interface at least is over 40 years old. Right? Think about that 40 years. Suppose that a library has existed for 40 years. They've got 40 years of testing behind them. They've got people going in and optimizing the code to make it super fast as it possibly can be. They've got people going in and writing more and more tests every day, right? You cannot possibly hope to, alone, to match all of the man hours that go behind all of that testing and development, right? So don't, right? Don't roll your own, generally. Generally, you don't want to roll your own functionality unless you have to, right? And by have to, I mean you're told by your instructor that you have to write this thing and you can't use the library to do it, right? Generally, you can use the library to do it though, right? Rolling your own, of course, refers to rolling your own solution out, among other things, right? Okay, again, in general, you don't want to reinvent the wheel. You don't want to reinvent the wheel. It's already been done for you. And of course, it goes back to the core of problem solving. Right? When asked to solve a problem, what is the first question you should ask? Is it already solved, right? So the answer is it already solved? Or at least mostly solved, right? We had to come up with a solution for rounding to cents. I don't know how to round, do you? I guess you could check that, you know, it's 0.5 and above, and then if it's less than 0.5 somehow, right? You could come up with something like that. Take off the integer part, and then if it's greater than or equal to 0.5, then you know, whatever. But who cares, right? I don't want to have to. I don't want to have to do that. Is it already solved for me? Is there already a round function? Yes, there is, but it doesn't quite get you where you want. It doesn't round to cents. It rounds to the nearest whole number. Okay, that's okay. I can adapt that solution, tack something, take a off-the-shelf solution, tack something else onto it, multiplying by 100, and then divided by 100, and I can get this new unit that is a unit of code that now has additional functionality by reusing old functionality. In other words, always look for off-the-shelf solutions. There are no mechanical engineers in here, are there? Or mechie folks, right? When you're designing a new machine, right, do you think, okay, well, it's going to have a motor. All right, well, before we design this machine, let's go off and design a motor. No, they just say, here are the specs for the kind of motor that we want, right? All right, well, they sell, this company over here sells that type of motor that will conform to your specs. Great, let's use it, right? You don't want to reinvent every little single detail in whatever you're trying to build, okay? All right, so how do you do it in C? We'll start with C first. As with variables, functions have to be declared before you can use them. Let me give myself some more room over here. There we go. Now it'll pop up. Right. In C, you declare a function using a prototype. So a prototype is kind of like that off-the-shelf solution. We build our first prototype and then we test it and see is it going to work or not, right? But in coding, a prototype is simply just a function declaration. A prototype defines or declares a function's signature. And a signature is its name, right? Its return type, the type of variable it returns, and any parameter types, inputs it takes. Okay? So it defines these three things. For example, it could take, just as a math function does, it could take two inputs, both of them a double. It could take three inputs. The first two are doubles, and then the third one's an integer. It could take no inputs at all. Right? But also, you have to declare what type of variable it actually returns. So let's go ahead and do this with our program over here. I want a round to cents function so that I didn't have to write this thing over and over and over again. multiply by 100, call round, divide by 100, call round, divide by 100, right? Don't copy pasta code like that. So I'm going to do it to show you what the syntax looks like. Then once we've established this on Thursday, I'm going to show you how to separate it into other files so you don't have one big giant God file. The God file is the file that contains everything, is everything, right? We don't want that, right? So I'm going to create a function called round to cents. That's its name, right? What's its return type? A double, right? It's going to take a double, right, $188.71 and fractions of a cent, and it's going to return $188.71 with those fractions of a cent taken off. So it does need an input, double. What should I call the input? Currency, okay, that's kind of what it is. Dollars, right? Okay, that's exactly what it is. Should I call it X? You can, but that's not very descriptive, right? So it takes in what? Amount? Dollars? What do you want? Dollars? All right. Although dollars, if I say $188.71, is that just dollars? I don't know. What's more generic than that? Amount or money? Oh, what kind of money? Well, US dollars? Okay, US dollar, USD. Avoid abbreviations. I'm just going to go ahead and go with amount. Right? So there are only two hard things in computer science, two difficult things in computer science. One of them is cache invalidation, and the second one is naming things. And there you could go back and forth all day. If you were working with a partner and you really wanted, I want to call it dollars, I want to call it USD, I want to call it amount, right? You can go back and forth and argue about it all day. That's called bike shedding. Have you ever heard that term? Right? It's arguing over inconsequential stuff, right? Just choose a reasonable name and move on. It's called bike shedding because the term comes from, suppose that you're designing a nuclear power plant. Super, super complicated engineering task, right? And so lots of people will come together and say, oh, okay, the design looks good. What color should we paint the bike shed out front, right? And now that's something easy to argue about. That really complex design, arguing whether or not that this is a good design or a bad design on the minutia of that, that's super difficult, right? It requires you to be an expert. And so now experts are going back and forth, right? But it's really easy to argue about the color of the bike shed, right? A bike shed where they would store their bikes coming to work, right? And so everybody can put input. I think it should be red. Well, I think it should be green. I think it should be yellow, right? It's easy to argue. The principle here is that it is easy to argue about inconsequential stuff. Right? It is difficult to argue about consequential stuff. And so what happens usually? You spend an inordinate amount of time on the stuff that doesn't matter. Right? Move on. So let's move on. With all of your prototypes, you need documentation. That is a requirement. Right? So if you write your own function, round to cents, you have to put in, and I'm going to say you should put in doc style comments, but you need at least some comments, documentation. So what does this function do?
Rounds, dollar off.
Rounds the given amount, right, to the nearest cent, right? It does what it says on the box. Right? This might seem a little bit redundant, but that's just because this is a symbol example, right? Round to cents is pretty clear. Why do you need this additional documentation? Just to get you into the habit. You're not always going to write something this simple, right? The name might be simple, but what it actually does under the hood might be complex, and that has to be documented. Right? Notice the syntax here. It's the return type, the name of the function, parentheses, because that comes from math, the input type, in this case a double, it takes a double, and then what's at the end? Semicolon. Why do we need a semicolon? Why do we need a semicolon when we declare a variable? Int foo. It's an assertion. I am declaring this variable. Its name is foo, and it has a type of integer. Its type is integer. I'm doing the same thing up here. I'm declaring that there is this function called round to cents. It takes a double, and it returns a double. Right? And I end that with a semicolon likewise. Now, does this say what the function does, or define what the function does, the code that actually executes when you call this function? No, it's just a prototype. It doesn't actually have the behavior here in C. So what you need to do is you need to define that later. Now, DRY, don't repeat yourself. Should I repeat the exact same documentation I had above? Nope. Documentation belongs, in C, documentation belongs with the prototype, not with the definition. Now with the definition, I actually need to say what this function does. So no semicolon, opening curly bracket, closing curly bracket, anything in between there is part of the function and executes when you call that function. So I'm going to simply return what? Round of amount times 100 divided by 100. Yeah.
You still have to define it as double.
This one? Yes. Yeah. The signature has to match. If I misspelled it, right, that's a different function. If I'm returning a different type, that's a different function. Well, that's definitely not, but an integer, right? Let's find out. GCC. Right. Conflicting types for round to cents and round to cents. One of them is an integer, one of them is a double. That ain't happening, right? And note that it is a full-on error. It's not going to compile. Right? If you have a different input type, that's a good question. Let's find out what happens. My guess here is a warning. Nope, good. Oh, it's an error. Right? Conflicting types for those two things. One of them takes an integer, one of them takes a double. Right? Now everything is hunky-dory and matches. Okay? Once you've defined it, you can use it. Instead of round, I can say round 2 cents. And pass it in the monthly payment. So much cleaner, right? And I can repeat that over and over again here. These three, anytime you find yourself writing the same piece of code more than once, strong hint, you should probably be doing this in a function. Thrice, 4 times, 5 times, this is screaming out to you at this point. Put me in a function, put me in a function, don't repeat me. Don't repeat yourself. DRY principle. What does the same thing look like in Java? Right? Documentation belongs here, but we do not have prototypes in Java. In Java, you just simply define the function. Okay? And I will steal the code from here and return a rounded amount. Of course, now that is part of the math library, math.round. Right? Now, why did we have to go math dot and then a function? Because where does this round function exist? In the math library over there, in the math class. So where does my round to cents function exist? In the loan class. So down here, if I'm going to use it, I would need to use something like not math.round, but loan.round 2 cents and the monthly payment, but that ain't going to compile. All right? This is how you should do it. It's not doing it because I forgot one. I also need to make it public so that everybody can see it. You can always see it inside the class that you declared it. But I'm going to add one other key word here. It's a key word that you've seen before right there. Static. Right? Note here that it's still not compiling. But once I put in static, it will compile and run. What's the difference between no static and static? Right? And what does static mean anyway? Just dictionary definition of static. Kind of, yeah, that it's static, it's unchanging.
It's not a variable.
that it's not variable because it can't vary, it can't change, right? Both of those are very close to the meaning in this context. In this in fact, in C, they have the static keyword, and it means something closer to that. But what it means here is that this function belongs to the class. It's static. It doesn't change with instances of the class. If I do something like this without the static, what I would have to do is I would have to create an instance of this class. I would have to say loan, my loan is equal to new loan, and then I can call my loan dot, what was it, round to cents? Round to cents. $188.71. Right? That's ugly. Right? That's object-oriented programming, but in this case, do you need an instance of the class loan? If you don't know what I'm talking about here, that's fine. We'll talk about object-oriented programming later on. This is ugly, right? Just make it static, and now anybody can use it just like the math library. You don't need an instance of the math library in order to invoke its functions. You just go math.function, and here I'm just going to go loan dot round to cents. Yeah.
Why isn't the scanner static then? Because you have to.
Good question, because what are you scanning? The standard input? Okay. That's not always going to be the case, though. Sometimes you can scan a file. Sometimes you can scan a web feed from, say, Twitter, right? Sometimes you can scan, what else would you want to scan? I'm drawing a blank off here, but basically a scanner is just a class that allows you to scan multiple things. So if you just had scanner dot next int, right? Well, what the hell are you scanning, right? You have to set up your scanner to read from the standard input, or to read from that file, or to read from that file, or to read from that file. And for that, you need multiple instances. I need 4 scanners because I'm going to read the standard input, I'm going to read file A, file B, and file C. So I would need 4 different scanners there. But square root, you're not reading a square root from a file, you're giving me the input, so there's no reason to have an instance of the math class. Right? Yeah?
So is creating a prototype in C at least before the program?
You have to declare it before you can use it, so I had to put it up here so that I could use it right here, and then I could wait to define it down here.
Okay. So is defining it after the program just a style thing?
That's a style thing, but also when we don't want a God file. We don't want every prototype and every function to, and the main to be all in one file. In fact, C doesn't do this. C puts standard library stuff in one file, standard input-output stuff in another file, math stuff in yet another file. We'll do the same. We'll take all of our utilities and put it into a different file, right? Round utilities over here, right? And then in that case, we would separate them further. The prototypes would go into a header file. So what do you think .h stands for? Header file, right? And then we would take all the definitions and put them into a source file. Keep everybody separate so that we can only bring in what we want. Right? And I'll show that to you on Thursday. Okay? All right, yeah, go ahead.
In Java, if we're using another function in the same class, we're just going to use custom.
If you had multiple files, yeah. I had my like roundutils.java, right? Then that would be an external class. And I would go roundutils.round2cents, right? And you should separate them, yes, because that's also a style thing. What does round to cents have to do with loans? Well, I mean, you use it, but they're not intimately connected. Maybe computing a monthly payment, that is something to do with loans, and so it belongs in this class. But round to cents or round to, if there's any currency out there that goes out to thousands or something like that, and they call those blahs, right? Et cetera, or they're currencies that are only whole numbers, like yen, right? There's no half yen, et cetera. But again, the real solution in real life is to use that currency class. But yes, you would separate things out so that math stuff is in the math class, loan stuff is in the loan class, customer stuff is in the customer class.
So if you have, if
then you would generally have to import round utils, right? And it doesn't exist here, but of course we'd have to make it, and we will on Thursday. That's why you have to import scanner, right? Okay? All right, so see you on Thursday then.